Hi class, in this video we're going to be talking about how to calculate for percent efficiency. So the formula for percent efficiency is the joules of useful output energy divided by the total joules of input energy times by 100%. Now we're going to calculate some percent efficiencies here for each of these devices, but we're going to round the answer that we get to the nearest tenth, such that if I get an answer for percent efficiency and it goes past the tens place, I would just round it to the nearest tens. So the first one we're going to talk about is the gasoline-powered sports utility vehicle, which can be found here. So the useful output energy is going to be 81 kilojoules, and I'm going to divide it by the total input energy, which is 675 kilojoules. Then I'm going to multiply that by 100%, and that will be how to calculate the percent efficiency. So in this case here, I only have one really important thing to say. Notice how I have kilojoules divided by kilojoules. That makes it so that my units cancel. So if you have something like 675 kilojoules, but let's say 81000 joules, you actually can't divide them because you don't have the same units. You have to have the same units in order to calculate for percent efficiency because the units have to cancel when you divide them. So just make sure you're aware of that. In this case, every one of these devices, I'm dividing by the same units, so I don't have to worry as much. Now let's just divide now that I have the same units. 81 divided by 675 is going to be 0.12. And now I have 0.12 times 100%. And if I multiply 0.12 by 100%, I get 12%. That means my gasoline-powered sports utility vehicle is only 12% efficient. That means if I put in 100% energy, only 12% of that energy is being used as a useful output energy to power my vehicle. Everything else is being lost to its surroundings in some way. Okay, another one would be gasoline electric hybrid vehicle. To calculate for this one, let's just take my output energy of 195 kilojoules and divide it by my input energy, so 675 kilojoules. Then I would times it by 100%. So in this case, 195 divided by 675 times 100%. After I round it to the nearest tenth, it's going to be 28.9%. Now the mid-efficient natural gas furnace, I guess I spelled that wrong there. So the mid-efficiency natural gas furnace, it's going to be 85 megajoules divided by 110 megajoules. And then I times that by 100%. And that's going to be equal to 77.3%. Let's calculate for the electric baseboard heater here. That's going to be 9.5 kilojoules divided by 9.5 kilojoules. Then I times that by 100%, which in this case would get me exactly 100%. So that means it's really efficient because that means my total output energy equals to my total input energy. So if I'm putting in 9.5 kilojoules of energy, I'm getting 9.5 kilojoules of energy out. Now for the alkaline dry cell, I'm going to have 74.38 kilojoules of energy, and it's going to be divided by 84.52 kilojoules of energy. I'm now going to times that by 100%. And if I compute that math there, I'm going to get 88%. Now for my fluorescent light bulb, I'm going to have 2.75 kilojoules divided by a total input of 12.5 kilojoules. So it's always output divided by total input. Then I times that by 100%, and my answer is going to be 22%. So I'm 22% efficient. Now for the incandescent light bulb, it's going to be 31 joules of energy divided by 780 joules of energy times by 100%. In this case, I'm going to get 4% for percent efficiency. So this does match up because incandescent light bulbs are much less efficient than fluorescent light bulbs because incandescent light bulbs releases a lot more energy to its surrounding as heat. So hopefully this gives you an idea of how to calculate for percent efficiency.